So what will happen when you increase the temperature? I just wrote that formula here. Resistivity is inversely proportional to m, inversely proportional to average charge density and inversely proportional to average relaxation time. Point is, what will happen? This is the conductor. You are increasing the temperature of this conductor, due to which these atoms or molecules of the conductor are going to vibrate more, right? Due to which more collisions are going to take place, due to which the time between any two collision, suppose this time between any two collision is going to decrease or increase due to more vibrations. They are now vibrating more vigorously. That means these collisions are supposed to take more often. So collision time is decreasing. Tau decreases, that means resistivity increases, and resistivity increases and hence resistance increases, because resistance actually depends on resistivity. This topic is included in temperature dependence of not resistance but resistivity. Alright, so note it down. Temperature dependence of resistivity is, I am giving you a formula, guys. Please do not I'll tell you how it is derived also, but please do not remember or memorize the steps. You can just do with the formula, because that is what your syllabus carries on. I am still giving you whole of the derivation. See, consider this is a conductor at temperature T1 having resistivity or having resistance rho naught. Okay, I would say rho 1 here. When we increased the temperature, let us say the temperature is T2 and resistivity becomes rho 2. So change in resistivity delta rho would be proportional to how much temperature you have increased. That means it would be proportional to change in temperature, and it would be also proportional to what was the initial resistivity. You got this point? No. Go back to your plus 1 where we deduce some expressions for length, coefficient of linear expansion, coefficient of bulk, coefficient of volumetric expansion, right? There also we did exactly the same method. If initial resistivity is low, what is the SI unit of resistivity? Resistivity is ohm meter. Suppose we have a conductor A having resistivity 10 ohm meter, and we have another material B having resistivity 1000 ohm meter, and in both these cases I am increasing the temperature by same extent. Let us say I have increased temperature by 20 degrees Celsius in both the conductors, in which case resistivity is going to increase more. For example, suppose this 10 ohm increases to 12 ohms, so change in resistivity is 2. Here this 1000 might increase to 1000, 20, 30. So here change of resistance would be 20 or 30. So compare this 20 and 30 as compared to 2. Where is change more? The change is more in case of initial resistivities, where initial resistivity was more. So in change in resistivity is also proportional to initial resistivity. If I add these 2 points, or if I accumulate these 2 points, what will I get? Change in resistivity is proportional to rho 1 delta T, and we have to put a constant of proportionality, where constant of proportionality is here in this case is alpha. So consider this sign. This is a proportionality sign, this is alpha. So please don't confuse. Alpha rho 1 delta T. Now if you can understand the formula in this respect, that is okay. If you can't, I am opening whole the formula. Delta rho is what? Change in resistivity, that is rho 2 minus rho 1. Alpha rho 1, what is delta T? Change in temperature. Change in temperature is T2 minus T1. So if you can remember the formula in this format, still better. Taking rho 1 here, rho 2 equals to rho 1 plus alpha rho 1 T2 minus T1. Take rho 1 common out, rho 2 equals to rho 1, 1 plus alpha T2 minus T1. This is the formula for final resistivity. So I would again repeat, please do not remember whole of this derivation, just remember this formula, and final formula I am writing it in different terms. Now I am writing it like this. This would be our, that was 6th formula, this would be our 7th formula. 7th would be, instead of rho 2 I am writing final resistivity is, instead of rho 1 I am writing initial or original resistivity into 1 plus alpha. This is the constant of proportionality. What was the name? This is called temperature coefficient of resistance, or it is also called temperature coefficient of resistivity. Both ways it is right, because calculate the units, you will understand why both ways it is right. 1 plus alpha rho naught change in temperature delta T, right? Delta T here. Instead of I am writing alpha T2 minus T1, so sorry, this is my mistake. This is from this formula alpha delta T. Write this formula, alright? So you don't have to do whole of the derivation. Now if you do the same steps for resistance, see how things are going to change. Consider initial temperature T1 for what? Resistance R1, and when you have increased the temperature, so resistance becomes R2. Similarly, change in resistance will be proportional to change in temperature, and change in resistance will also be proportional to initial resistance. So whenever you change rho with R everywhere, finally your answer would again be like this. R will be equal to R naught 1 plus alpha delta T. So that is why alpha is always both ways called temperature coefficient of resistance. So ultimately conclusion, what is the conclusion? That with increase in temperature, resistivity increases because tau decreases. Tau decreases, resistivity, what is tau? Average relaxation time. Collision between two atoms or collision between an electron between two atoms will decrease, the time will decrease, due to which resistivity increases. Wait a second, what happens to average charge density? Average charge density is actually independent of any other physical change, right? It remains the same. So resistivity increases, R is directly proportional to resistivity, resistance will increase. So increasing the resistance, increasing the temperature, resistance also increases.